So now we're gonna start with the rule number 4. So rule number 4 is, actually it is CH2OH, and it is C double bond OH, aldehyde. N1 we have acid. So in case of aldehyde we have hydrogen, then oxygen. Here we have hydrogen, oxygen, and oxygen. Here we have oxygen, oxygen, and oxygen. So the priority will be first over there, then there will be second, and it will be third priority over there. Now we're gonna talk about some questions regarding that. We have CH2SH, then we have CH2OH, then we have aldehyde. So which gonna have first the priority? The priority will gonna have first, we have here H, H, and S. Now H, H, and oxygen. Now we have oxygen, oxygen, then oxygen. 3 oxygen we have. So the first priority we're gonna have is that one. Then no, not one. The first priority we're gonna have is sulfur, because when we get the maximum, this is quite important. When we have the maximum mass of any substance, the maximum mass, then we will give priority to it. Then we will second to it, and then we will third to it. It is quite important. Now next question, we have a group like here we have nitrogen, and we have here nitrogen over here. Then the group attached here is carbon, nitrogen, and nitrogen, and the group attached here is hydrogen, carbon, and nitrogen. So the priority over here carbon, hydrogen, and hydrogen. Now we're gonna look about rule number 5. Now we're gonna look about rule number 5. So rule number 5 says that like we have a substance like CH double bond NH, and we have substance like CH NH2 and NH2, right? So we have substance like this, CH double bond NH and CH2 NH2. So which we gonna have the more priority? We're gonna have the priority of more CH double bond NH, because when we convert into imaginary bond CH double bond NH, and here will be a CH NH2. Carbon has hydrogen, nitrogen, and nitrogen. Okay, hydrogen, nitrogen, and nitrogen. But here we have hydrogen, nitrogen, and nitrogen. That hydrogen, carbon, and nitrogen. Wait, let's change it. Here we have hydrogen, carbon, nitrogen, carbon, hydrogen, nitrogen, carbon, and hydrogen. So we have carbon, hydrogen, and nitrogen. Here we have nitrogen. So with this group we have this priority, because the number of compound, because this is simple, because we have nitrogen to the more prior group, right? Now very important things regarding this point. We have C triple bond C, CH3, and we have CH3, then CH3, then CH3, then we have CH3. So when we convert into imaginary bond we have seen how do we convert into imaginary bond, CH3, and we convert into CH3. How do we convert into imaginary bond? Like we have that carbon directly attached with the carbon. So in order to compare the all 4 bonds of carbon, what we do that carbon, and carbon, 3 carbon are attached to it. Here also 3 carbon are attached to it. Here also 3 carbon are attached to it. Here also 3 carbon are attached to it. Right. So all the priority are same, but we give the priority to the real bond. Then we give priority to the imaginary bond. Real bond, then imaginary bond. That's how we give the priority. Now here comes out to be rule number 6. Now Rule number 6. So what rule number 6 says? Like we have this group and we have this group. So which group gonna have the more priority? This group gonna have the more priority. Why? Because when we compare the first carbon same. Then we compare the second carbon same. Then we compare the third carbon is same. But to the third carbon, and here is the third carbon. To the third carbon, then we go to fourth carbon. Again, fourth carbon is same. But to the fourth carbon, there are two carbon attached. One this and one this. So two carbon are attached. But here with the fourth carbon, only fifth carbon is attached, which is single. So to this carbon, there are one carbon, two carbon, and hydrogen. And this to the fourth point, there is one carbon, one hydrogen, and one hydrogen. So carbon, carbon, and hydrogen are there, and carbon, hydrogen, and hydrogen there. So then the smaller the ring, more will be the priority. This is quite important. Smaller the ring, more will be the priority. We have to check also, but in general, smaller the ring, more will be the priority. Like if I write some examples, like we have hydrogen, carbon, then fluorine, double bond, carbon C double bond O OH, then we have CH2OH. The priority will be 1 here, the 2 here. The priority will be 1 here, then the 2 here. So simply it is 1 1 Z. It is Z. Now next we're going to talk about an example. We have this compound and we have cyclopentyl group. Then we have C double bond NH. C double bond NH. C triple bond N, and we have C double bond NH, CH double bond NH. So priority to this will be 1, this will be 2, this will be 1, this will be 2. Then it is also Z. Now we're going to talk about third type of geometrical isomer, which is known as syn-anti. Syn-anti. In like how do we form? This is the third. In the double bond, we're going to talk about first the double bond in which is trans, then we have Ze, then we have syn-anti. So how we form syn-anti? We know that R1 C double bond R2. This is oxime that react with hydroxylamine. This is hydroxylamine. So here water molecule moves, then R1 C R2 double bond N. Lone pair could be above and lone pair also could be below. OH and double bond, then R1, then R2. Lone pair could be above, lone pair below. So when we have enzyme aldol, aldehyde plus hydroxylamine forms endoximes. Like it forms endoxime. How it forms endoxime? Like we have R1 RC double bond OH. It reacts with H2NOH. Then it reacts and form RCH double bond N OH, and we have lone pair. Now it has RCH double bond N. Here we have lone pair and we have OH. So this is R group is with OH. So it is anti group and it is a syn group. We take reference to the hydrogen and OH. If hydrogen and OH are anti, this is called anti. And then together, then it called as syn. Okay, this was the endoxime. Now what about ketoxime? When we have ketoxime, we have CH3, C double bond O, then we have CH2, then CH3. When this react with HNHOH, water molecule removes, then it forms CH3, C double bond N double bond O, OH, then C2H5. Or it forms C double bond N, OH, C2H5, then CH3. So one is syn, one is anti. So which is syn and which one is anti? So if we look at the first compound, it is known as syn. Syn ethyl methyl, since ethyl methyl ketoxime, and it is known as anti-ethyl methyl ketoxime. Because the OH group is together with C2H5, then it is syn C2H5 ethyl, then methyl, then ketoxime. It is anti then ethyl, which is anti to the OH, then methyl, then ketoxime. So everything goes around the OH. Okay, everything goes around the OH. Like every ketoxime has two types of name. Like example, we have PHC double bond N OH. This is known as syn ethyl phenyl ketoxime, and it is known as anti phenyl ethyl ketoxime. Right, we have another example. See, CH3. Here we have OH and we have oxygen. So here it is also called syn tertiary butyl methyl ketoxime. Also it could have anti methyl tertiary butyl ketoxime. So we have two types of group. Now we're going to look about counting of geometrical isomerism. Now we're going to talk about counting of GI. How do we count the total number of GI when we have more than one double bond or more than one double bond? Then count of GI. How do we count geometrical isomer? We count geometrical isomer like we have CH3, CH double bond, CH and Cl. So it has two geometrical isomers, simple, easy. Now when we talk about like CH3, CH double bond CH, then CH2, then CH double bond CH and Cl. Now it has two sides through which it can show GI. So if one is E, another could also be E. One is E, another could also be Z. One is Z, another could also be Z. One is Z, another could also be E. So there are four chances, right? So when it is unsymmetrical, so there are four GI possible here. Okay. So but every time we can't count, right? Every time we can't count. So when we have example, when we have, like we can write it as a case A, case 1, when we have unsymmetrical geometrical isomer. When we have unsymmetrical geometrical isomer, so how do we write? CH3, CH double bond CH, CH2, CH double bond CH, then Cl. So it is actually unsymmetrical geometrical isomer. So how much? 2 to the power 2 equals to 4. The formula is 2 to the power n. Right? When we have CH3, CH double bond CH, CH double bond CH, then CH3, then CH3. Here we have two geometrical center. Here also 2 to the power 4. So this is actually unsymmetrical, but this is asymmetrical. If we write CH3, CH double bond CH, CH double bond CH, then CH3, then it is symmetrical. We are not talking about right now to this. This is symmetrical, right? So n is the number of geometrical isomer. N is number of double bond which shows geometrical isomer. Then it is total GI equals to 2 to the power n. This is the total GI, right? Example, with example, let's say we have let's say if we take the example, let's say if we take the example like We have CH3, CH double bond CH, CH double bond CH, then CH double bond CH and Cn. Here the number of sides which show GI are 1, 2 and 3. So answer 2 to the power 3 equals to 8. Now again, if we write more examples, now if we try to write the more example, actually the number of geometrical isomer is 2 to the power 3, which is 8. And in this case, how many GI? Again you will say 1, 2, 3 and 4. But this side doesn't show GI. So 2 to the power 3, it is also 8. And how much to this? This is also 1, 2, 3, 4, 5 double bond. But this doesn't show here, this doesn't show here. This is also 2 to the power 3 equals to 8. But when we talk about the symmetrical compound, when we talk about symmetrical compound, when we talk about symmetrical compound, wait. When we talk the symmetrical compound, so how do we count the GI? In case of symmetrical compound, how do we count the GI? In case of symmetrical compound, example we have CH3, CH double bond CH, CH double bond CH, then CH3. So one could be Z, another could be E. One could be Z, another could be Z. One could be E, another could be Z. One could be Z, another could be E. Z and Z first could. E and E, ZZ, EZ and ZE. So these are the identical. So how much we count? There are 3. So the formula comes out to be 2 to the power n minus 1 plus 2 to the power p. P equals to n by 2 minus 1 is n is even. And p equals to n minus 1 by 2 if n is odd. Right, if n is even and n is odd. So the questions comes out to be n equals to here, n equals to 4. And 2 to the power 4 minus 1 plus 2 to the power 4 by 2 minus 1. That is 2 to the power 3 plus 2 to the power 1. That is 10. Here the number of GI are 10. But when we count the next one, we have N, OH, CH double bond CH, CH double bond CH, and C double bond N. N equals to 3. 2 to the power 3 equals to 8. Then we have 3 sides 1, 2 and 3. Now we have N, OH, CH, CH double bond CH, CH double bond CN, OH. We have 2 to the power 4 minus 1 plus 2 to the power 4 by 2 is 1 equals to 10. This was unsymmetrical and this was symmetrical. In case of symmetrical, we have 1, 2, 3 geometrical centers. So the answer is here 10.